Similarly, if we ignore the x coordinate, or let x equal to a constant, we get in the yz coordinates the parabola z equal to minus y squared, which remember is your, if you want to call it, a negative parabola. So in the yz coordinates down there, we get that parabola. So in the xz coordinates, we get the positive parabola. In the yz coordinates, we get the negative parabola. In the xy coordinates, that is when we let z equal to a constant, we get the equation given by x squared minus y squared equal to the constant k. And that we know is a hyperbolic shape in the xy coordinates. So we get this hyperbola and that hyperbola there. And this is now in the xy coordinate system. And we need to put all this together. Let me remove that. So in the three-dimensional system given here, we've got the x coming out of the page, the x-axis, and the yz coordinate is on the page. So the yz plane is the page itself. The xz plane is the plane that is coming out of the page, and the xy plane is the plane on the floor. Recall above we said that in the xz coordinates we get the positive parabola. So that is the positive parabola that is coming out of the page. In the yz coordinates, that is on the page itself, we get the negative parabola, but it's perpendicular to. So we got one parabola that's positive, that's the positive parabola. This is the negative parabola, but the two parabolas are perpendicular to each other. And when we view this from the top, i.e. when we project on the xy plane, we get these hyperbolic shapes. And when we put this together, think of the two parabolas having the following profile. Okay, so that is your parabola which is positive. This is your parabola which is negative, but the two are perpendicular to each other. One is on the page and the one is coming out of the page. And you can imagine someone sitting on the parabola with his in the parabola on the page, and this leg is coming out of the page and that leg is going into the page, and hence we have the saddle.